Welcome back. This is the final episode of Phase 1 in the iTrain signals series, where we've been learning about virtual signals in the iTrain software before moving on to the real model signals in Phase 2. In this instalment, we cover multi-role signals, offering clear explanations for beginners and a deeper insight for those wishing to know more. Before we get started, let's quickly review some essential terms used here. They might seem simple, but they're frequently misinterpreted, particularly during translation. In iTrain, a block can have two directions. Direction next, indicated by a solid arrow, and direction previous, shown with a dashed arrow. When moving in direction next, left to right in this example, the left side marks the start of the block, while the right side is the finish or end. If you travel in direction previous, these roles are reversed. It's important to know which side of the block is the start and which is the end, because multi-role signals are always positioned at the end of the block relative to the travel direction. The terms unrestricted and restricted denote the permissible speed states of a turnout. An unrestricted state allows trains to operate at line speed across the turnout, typically associated with the straight, non-diverging route. In contrast, a restricted state imposes a specific speed limit, generally applicable when traversing a curved or diverging path where the main line branches. Single-role signals, shown shaded in blue here, are devices designed to perform only one function, such as acting solely as home, warning, or shunt signals. A multi-role signal is a versatile device that performs home, warning, and shunt functions, unlike single-role signals which serve only one purpose. For example, this is a multi-role signal because it has home and shunt functions. This signal is a special case, being two single-role signals, one performing only home and the other performing only warning, but both on one mast. The British signals are all multi-role, because they each perform home and warning functions. Regional signal systems are generally either speed-based or route-based, though some combine both approaches. Speed-based signals, common in continental Europe, show only speed information. In iTrain, speed-based signals use turnout speed states to trigger the various home signal aspects. While route-based signals, common in the UK, indicate only the upcoming route. They respond only to route changes and by definition should not react to restricted or unrestricted speed states. However, in iTrain, a restricted turnout state is in fact used to trigger a diverging or feather state when the route splits. The term aspect or signal aspect used here refers to the various visual states of a signal. Within the signal properties, the logical term used is states. So this logical state produces this visual aspect, not to be confused with the aspect accessory device of the same name. And lastly, a note for the future. In this tutorial, we use the term warning signal to be consistent with the wording used in iTrain 5.1. In version 6, that will change to distant signal. All the supporting materials used for this tutorial, including the iTrain 5.1 signal rules document, which is a supplement to the main iTrain user manual and is your primary reference for these signal tutorials, and copies of the layout files used in this episode are available from a new link on the official iTrain website, in the Downloads section and under the Manuals list. Setting up multi-role signals in iTrain involves a sequence of straightforward steps. We'll highlight each one and include tips to ease your progress. Step 1. Placing the signal in a block. Begin by positioning your signal within a block on the switchboard. Here we are using a modified version of the iTrain demo layout file with all the signals removed. It's available from the Downloads section. Pro tip: select any multi-role signal at this stage. It's just a placeholder and can be easily swapped later. Placement rules differ for single-role and multi-role signals. Single-role home, warning and shunt signals each have specific locations as demonstrated in the last episode. But a multi-role signal is always placed in the same location, somewhere near the end of the block, and only one is allowed per direction per block. Ensure it's orientated for the direction of travel. For example, German signals operate from the right-hand side of the track and British signals from the left. You can move ahead and place a signal in every block now if you wish. They are always placed in a similar location, somewhere near the end of the block. Add a second signal in bidirectional blocks if needed and orientated for each direction. A multi-role signal can combine all three roles, but note its warning function is always for the home signal in the block ahead, not the home signal contained within the same block, like with this single role configuration. That latter role requires a separate warning signal, and consequently multi-role and single-role signals can coexist in the same block, as shown here. Step 2. Defining signal properties. Double-click your multi-role signal to open its properties editor. For virtual signals, just leave a clear, short, unique name and optional longer description. Leave the other settings at their default values for now, unless you have a specific reason to change them. Pro tip: keep names short and concise with a hint to their location. Short names are faster and more efficient for iTrain to process and are easier for people to identify too. So leave longer descriptions for the description field. Press OK to save it, then check that the signal name is listed in the Accessory tab on the left. This confirms that iTrain is now aware of this signal. Step 3. Grouping the signal with the block. Ensure the signal is correctly associated with its block, following iTrain's standard grouping procedures. Troubleshooting tip. If the signal doesn't respond to block changes, verify it's properly grouped and not mistakenly linked to another block. While items are grouped in a block, only its track sections should be orange, with no orange sections elsewhere. Step 4. Assigning signals in block properties. Open the block properties, select the relevant direction tab and use the Auto-Fill feature to assign signals. A multi-role signal will be listed only in the Home Signal field, even if it also serves warning or shunt functions. Single-role signals, if present, are listed in their respective fields. Troubleshooting tip. If the signal's name does not appear, first check you have selected the correct Direction tab. Then click Show All and see if the name is listed. If it is now listed, it means it's assigned elsewhere and not with this block, so check its grouping. Now repeat steps 2 to 4 for each of the other signals. Step 5. Setting the root logic to trigger the required signal aspects. This is about how the speed and route of an automated train is governed, not by the signals, but by the prevailing block and turnout conditions. Signals are simply reacting to those conditions, not setting them. How the blocks and turnouts govern the route and speed was thoroughly explained in video 5, so please refer to that episode. Our task now is to use that knowledge to analyse the route ahead, to set the logic so that iTrain selects the correct aspect to display based on the block and turnout conditions and the enabled signal states. This step is key for realistic operation, whether you're working with speed-based or route-based signals. To help solidify your understanding, we have created modified demo layouts, illustrating both German speed-based and British route-based signalling in action. These layouts are available for download from the official iTrain website and are perfect for experimentation. German speed-based signals. Here, signal aspects are determined by the maximum safe speed along the route, especially at turnouts. For example, the home function on a multi-role signal can display stop, proceed at unrestricted speed, or proceed at restricted speed, depending on the path ahead. The unrestricted aspect will always display if the path into the next block contains no turnouts, or if it contains turnouts, all the active states in the path are set to unrestricted. A restricted aspect, of which there may be more than one, will only be displayed if the path into the block ahead includes turnouts, in which at least one has a restricted state. The signal always indicates the lowest permissible speed in the path. To display a specific speed aspect, a turnout must include the same restricted numerical state somewhere in its path. This can even be on the straight route. But again, it must be the lowest permissible speed in the path. See video 5 for more information. Practical tip. If your speed display isn't correct, check the turnout settings to ensure the required speed state is the lowest viable speed for that route through the turnouts, and that the state is enabled in the signal properties. British route-based signals. In these systems, the signal aspect reflects the alignment of the route rather than its speed. A straight or curved path that does not diverge will show a green clear aspect when allowed to proceed, regardless of whether the turnout states are branch or straight, unrestricted or restricted, because there is only one choice of route ahead. Where the track diverges, a diverging or feather aspect is required. So select a signal that has a diverging state and enable it. To trigger that state, a restricted turnout state must be present in at least one of the turnout paths. Practical tip. If the diverging aspect does not appear, make sure you've assigned the correct signal type and enabled its diverging state. In the diverging path through the turnouts, ensure at least one turnout has the required restricted state set. Here I am using the straight path to trigger the feather. Pro tip. If you have a signal with two or more feather aspects, see the post on the iTrain forum. Search for signal with two or more feathers. Speed-based and route-based signals that have caution, warning or distance aspects, including preliminary aspects, are displayed simply by enabling the relevant state or states in the signal. It will then automatically be configured to mirror the state of the home signal ahead. Pro tip. To test a caution or warning aspect, always activate a route. Without a route, the warning signal will not react to changes in the home signal when a turnout is between the two signals. Shunt aspects, when enabled, are only displayed during a shunt route, as indicated by the teal colour. The British signals do not include a shunt function, so a separate shunt signal needs to be used. Here I have used the Swiss SBBL shunt signal with these two states enabled. This will operate the real British signal on your layout with red and white lights. In the block properties, pressing autofill assigns the single roll shunt signal to the shunt field and the multi-roll signal only to the home field. Here is the setup using German multi-roll signals with the shunt state enabled. In the block properties, only the home field is assigned. Testing the signal operation. The basic operation of a signal can be tested by manually changing its state. But for a thorough test, use an automated route, especially for warning and shunt signals. Manually changing a signal's state to test it while a route is running may not produce the expected result, so allow the operation to complete automatically without interfering. If a signal doesn't operate as expected during a route, confirm that your logic reflects the correct route conditions, that the appropriate signal states are enabled, and unused states disabled. And remember, in fully manual driving mode, signals do not operate automatically. In that mode, you are in complete control of the position of turnouts, setting the signal aspects and controlling the train speed. Notice how I will be able to drive through the red signal ahead because the speed is unchanged. So you are solely responsible for the safety of the train by obeying the signals, timely setting of the turnouts, preventing collisions, and safely bringing the train to a halt. Semi-automatic driving mode is the same as manual mode, except that iTrain will safely bring a moving train to a halt if it encounters a red signal. Watch as iTrain safely slows a moving train to a halt at the red light. But otherwise, you are in control of the position of turnouts, the state of the signals, avoiding collisions, and the speed of the train, including bringing it to a halt at its destination. It is also possible to drive an instant route in manual or semi-automatic mode by holding down the control key and then dragging and dropping, which allows you to choose either type. The route is reserved, the turnouts and signals are set for you, but you still control the speed and need to obey the signals. In automatic mode, iTrain is in control of everything. So, signals are only automated when a train is driven by an automated route. With virtual signals, you can experiment freely in offline mode. This is a safe way to build confidence before controlling the real hardware. Each of the modified demo layouts shown here, the British layout using route-based signals, or the German layout using speed-based signals, includes examples of blocks with non-diverging, straight, or diverging split routes. A block where single roll and multi-roll signals coexist, and bidirectional blocks using all available signal functions. By studying these layouts, you'll see how restricted and unrestricted aspects are triggered by turnout settings, and how multi-roll signals can provide both home and warning functions based on the train's route. A multi-roll signal is simple to install and assign because it is always placed in the same location within a block and always exclusively assigned to the home signal field. The tricky bit is analysing the path and setting the route logic correctly to produce the desired aspects. But once again, Video 5 will give you the skills to be successful at that. In the download section, I have also included my notes on how and why each of the German signals are configured to operate in the way they do, and notes on how I tested the operation of each of the signals. So if you wish to dig deeper, explore those notes. You've now got the fundamental knowledge and step-by-step guidance to set up multi-roll signals in iTrain and bring more realism and flexibility to your model railway. So download the demo files, explore how the signals are set up and configured, then use the empty layout file to rebuild a signal system using the signals from the region you are modelling. You can even take the completed layout files and simply change each signal with an equivalent from your regional group. Remember, it's normal to have questions, especially as you encounter new scenarios. We learn most when things go wrong, so don't be afraid of failure or experimenting. When you need help, head over to the iTrain forum. Be sure to always attach your .tcdz layout file when posting, as this helps others provide targeted support. So that concludes Phase 1 using only virtual signals. In the next episode, we either take the leap into controlling real physical signals on a layout, or it will be about the release of iTrain 6, whichever comes first. Until then, happy experimenting and bye for now.